friends. This video is brought to you by mywayteaching.com.
Let us start with the properties of square numbers. The first property states that all square numbers have 0 or 1 or 4 or 5 or 6 or 9 in the units place. That means a square number can never have 2, 3, 7 or 8 in units place. Let us try to verify. Let us take the squares of 1 will be 1, square of 2 will be 4, 3 will be 9, 4 square will be 16, 5 square will be 25, 6 square will be 36, 7 square will be 49, 8 square will be 64, 9 square will be 81, 10 square will be 100, 11 square will be 121, 12 square will be 144, 13 square will be 169, 14 square will be 196, and 15 square will be 225. Clearly we can see that in ones place either we are having 0 or 1 or 4 or 6 or 5 or 9. Our second property states that square numbers can only have even number of zeros at the end. So let us verify it. Let us take 10 square, which will be 100. If we take 20 square, it will be 400. Let us take 80 square, that will be 6400. Let us take 100 square, that will be 10,000. Let us take 200 square, that will be 40,000. Let us take 900 square, that will be 8,10,000. Just observe the number of zeros in each square number. In 100 we have 2 zeros, 400 has 2 zeros, 64 has 2 zeros. So all these are even zeros. Let us see in 100 square we have 10,000. Again there are 4 zeros, which is a even number. 40,000 also has 4 zeros, it is again a even number. 8,10,000 also has 4 zeros, so it is a even number of zeros. Third property states that square of even number are always even number and square of odd number is always odd. Let us verify. Let us take some even numbers. We know that 2, 4, 6 are even numbers. Then 2 square will give us 4, 4 square will give us 16, and 6 square will give us 36. That means square of even number is giving another even number. 4, 16, 36 all are even numbers. Now let us take some odd numbers. Let us take 3, 5, 7. Then 3 square will give us 9, which is an odd number. 5 square will give us 25, which is again an odd number, and 7 square will give us 49, which is again an odd number. Fourth property states that a perfect square number when divided by 3 leaves remainder 0 or 1. Let us take some perfect square numbers. Let us take 4, 16, 25, and let us divide them by 3. What we have? In all these cases, we will get remainder 1. Now consider another perfect square, 9. If we divide by 3, we will get remainder equal to 0. Let us take perfect square number 36. If we divide by 3, again remainder will be 0. Hence, we have verified that a perfect square number when divided by 3 will leave remainder either 0 or 1. Fifth property states that a perfect square number when divided by 4 leaves remainder 0 or 1. Note that this property will not hold for 1. 1 square will be 1, and which is not divisible by 4. Other than 1, let us take some square numbers. Let us take 4, 9, 16 and 25. Then 4 can be written as 4 ones are 4 plus remainder 0. 9 can be written as 4 into 2 plus 1. 16 can be written as 4 into 4 plus 0. 25 can be written as 4 into 6 plus 1. Clearly we can see that these perfect square numbers on division by 4 will either give remainder 0 or 1. Next property states that the difference of squares of two consecutive natural numbers is equal to their sum. Let us verify. Let us take 4 square, that is 16, and 3 square, which is equal to 9. Now 4 square minus 3 square will be equal to 16 minus 9, that is equal to 7, and which can be written as 4 plus 3, and hence we can say that difference of the squares 4 square and 3 square are squares of two consecutive numbers is equal to their sum, can be written as 4 plus 3. That means if we have 9 square minus 8 square, it will be equal to 9 plus 8, that is equal to 17. Let us verify. We know that 9 square is 81 minus 8 square is 64, and that gives us 17. So hence verified. Please understand that two consecutive natural numbers means if we are taking 3, the next number will be 4. They are called consecutive numbers. That means the number and the next number. Before stating the property, let us study a pattern. Let us see 1 square. 1 square is equal to 1. This 2 square, which is equal to 4, that can be written as 1 plus 3. 3 square is equal to 9. That is equal to 1 plus 3 plus 5. 4 square can be written as 1 plus 3 plus 5 plus 7. That means we have 1 square equal to 1. That is the sum of first one odd natural number, similarly 1 plus 3 is the sum of first two natural odd numbers. 1 plus 3 plus 5 is the sum of first three natural odd numbers. 4 square is the sum of first four odd natural numbers, and hence we come to the conclusion that the square of a natural number n is equal to the sum of first n odd natural numbers. That means if we have n square, it is going to be sum of first n odd natural numbers. Let us study some more facts about square numbers. If a number has 1 or 9 in the units place, then its square ends in 1. Let us see. Say the number is 1, then 1 square is equal to 1. If the number is 9, then 9 square is equal to 81. If the number is 11, then 11 square is equal to 121. If the number is 19, 19 square is equal to 361. If the number is 21, then 21 square is equal to 441. Clearly, all the numbers are ending with 1 whose units place was either 1 or 9. So the property holds. Another fact is that if a square number ends in 6, the number whose square it is will have 4 or 6 in units place. Let us consider some square numbers which end in 6. We have 16, then we have 36, we have 96 and 256. We know that 16 is a square of 4, 36 is 6 into 6, 196 is 14 into 14, and 256 is 16 into 16. Clearly, we are either having 4 or 6 in the units place. Like in 14 we have 4 and 16 we have 6. And so this fact also holds. Let us discuss another fact about square numbers. Let us take 4 square. We know that it is 16 and 5 square is 25. Let us see how many numbers between 16 and 25 are not the perfect squares. That means 17 is not a perfect square, 18, 19, 20, 21, 22, 23 and 24 are not perfect squares. Let us count them. 1, 2, 3, 4, 5, 6, 7, 8. So we see that these are 8 in numbers. We also know that 8 can be written as 2 into 4. That means if we take 4 as n, then 5 will be n plus 1 and 8 is equal to 2 times n. And now we are in a position to state that there are 2n non-perfect square numbers between the square of the number n and n plus 1. We have taken the square of number n, that is 4 square, and n plus 1 is 5, so 5 square, and the non-perfect square numbers between them is 8, which is equal to 2 times n. Another important fact about square numbers is that sometimes they follow a fixed pattern. If we understand the pattern, then we can find the square of more numbers in that series. Let us take an example. We know that 1 square is 1, 11 square is 121. Let us find 111 square. It will come out to be 1, 2, 3, 2, 1. Let us write it differently. We have 1 square equal to 1. We have 11 square equal to 1, 2, 1. We have 111 square equal to 1, 2, 3, 2, 1. From here, can you understand the pattern? We have a single 1 here, so only 1. Then we have 2 ones. That's why we are reaching 1, 2, then reducing back to 1. We have 3 ones, so we are going to 1, 2, 3, and then reducing back to 1. Let us see what happens if we have 4 ones. According to our pattern, it should go 1, 2, 3, 4, 3, 2, 1. You can verify this by multiplying 1111 with 1111, and you will get the same answer. Now if we are asked to find the square of 1, 2, 3, 4, 5 ones whole square, then it would be easy for us to follow the pattern. We will write 1, 2, 3, 4, 5, 4, 3, 2, 1. Likewise, we can find the square of any number of ones following this pattern. We know that square of a small number is easy to find. If we have to find 3 square, it would be 3 into 3, that is 9. 7 square would be 7 into 7, that is 49. But if we have to find 23 square, it would be 23 into 23. So instead of multiplying and finding, we can rewrite as 20 plus 3 whole square, which is equal to 20 plus 3 into 20 plus 3. Now we can open the brackets by multiplying 20 with 20 and then 20 with 3. That will give us 400 plus 60 and then 3 with 20 and 3 with 3 will give us 60 plus 9, and on adding we get 529. Hence we can find the square without actual multiplication.